Two-dimensional kinematics. In the future, I might have a flying car with an engine mounted on the bottom and an engine mounted on the back. These engines are perpendicular, with one mounted in the x direction and one mounted in the y direction. When the engine mounted in the x direction fires, the car only moves in the x direction. And when the engine mounted in the y direction fires, the car only moves in the y direction. Each of these motions by themselves is a one-dimensional motion that can be described with a displacement, velocity, and acceleration. If motion is only in the x direction, we say that the displacement, velocity, and acceleration vectors each only have one component, an x component. And motion in only the y direction is described by vectors with only y components. If acceleration is constant, we can describe the x component motion and the y component motion with kinematic equations. We think of these as the two-dimensional kinematic equations, even though each equation is in only one dimension. You'll find that these are identical to the one-dimensional kinematic equations you've already seen, but they're written to reflect either x-direction motion or y-direction motion. In the x-direction kinematic equations, we put an x subscript on the initial velocity, final velocity, and acceleration variables. We do the same for the y-direction kinematic equations. In the x direction, we can call the displacement x, and in the y direction, we can call the displacement y. And t represents the elapsed time in both sets of equations. We can use these two-dimensional kinematic equations to describe the motion of an object traveling in both the x and y direction, and if acceleration in each direction is constant. Take my futuristic car, for example. It has an initial x velocity and an initial y velocity. If both engines fire at the same time, the back engine causes a change in the x component of the velocity, and the bottom engine causes a change in the y component of the velocity. The change in x is independent of the change in y, and vice versa. The reason we can use the x and y kinematic equations to describe this motion is because the x part of the motion occurs exactly as it would if the y part did not occur at all, and the y part of the motion occurs exactly as it would if the x part of the motion did not exist. Because of this, we can treat a two-dimensional motion as two separate one-dimensional motions. Let's work a two-dimensional kinematics example problem. In the x direction, my futuristic car has an initial velocity component of 20 meters per second and an acceleration component of 25 meters per second squared. In the y direction, the initial velocity component is 15 meters per second and the acceleration is 10 meters per second squared. At a time of t equals 10 seconds, find the x and y components of my car's displacement. First, let's draw a picture. Here's my car at the origin of an xy graph with an initial x and y component of its velocity. We also have x and y components of constant acceleration. After a time t, the car has moved to a new location with x and y components of its displacement. What values are we given in the problem? We have the x component of the initial velocity, which is 20 meters per second, the y component of the initial velocity, which is 15 meters per second, the x component of the acceleration, which is 25 meters per second squared, the y component of the acceleration, which is 10 meters per second squared, and a time of 10 seconds. Now, what are we looking for? We're looking for the x component of the displacement and the y component of the displacement. Now we need some equations. We know that we can treat this two-dimensional motion as two one-dimensional motions. So let's start with the x motion. This equation for x motion from our table of kinematic equations contains our known values of v1x, a sub x, and t, and our unknown value of x. Now we just plug in our known values for v1x, a sub x, and t. Then we use our calculator to solve for x, getting a value of 1450 meters for the x component of our displacement. Now we can look at the motion in the y direction. We're given values for the same variables in the y direction as we were in the x direction, so we can use the y component form of the same kinematic equation. Next, we plug in our given values, and we use our calculator to solve for y, getting a value of 650 meters for the y component of our displacement. So, after 10 seconds, my car has moved 1450 meters to the right and 650 meters up. Remember, in these problems, you should treat the x motion and the y motion as separate motions. Just list all of the components you're given as you start to work the problem, and then go from there.